this video, we're focusing on Section 2, Electrical Circuits and the Basic Symbols. But first, let's revise what we learned in the previous video.
Vale, vamos a repasar muy rápidamente lo que vimos en el anterior vídeo en el que se explicaba lo que es la electricidad. Esta definición de aquí es tan buena como cualquier otra. Conviene puntualizar que puede ser que las cargas no estén en movimiento y entonces estaríamos hablando de electricidad estática, que es ese fenómeno que se observa pues, cuando te frotas un bolígrafo contra la ropa y se pegan los papelitos de papel. Pero lo que nos interesa en esta unidad es la corriente eléctrica. Entonces, para entender qué es la corriente eléctrica, conviene entender cuál es la estructura de un átomo. Este dibujo de aquí representa la estructura de un átomo muy simplificado. Los átomos no tienen esta pinta en realidad. Y ya vimos que los protones tienen carga positiva, los electrones tienen carga negativa y que si nos vamos a un material como el de este dibujo de aquí que representa un cable o intenta representar un cable, los átomos del material conductor, podría ser cobre, por ejemplo, los electrones que tienen libres, pues se mueven libremente de un átomo a otro, pero si aplicamos un voltaje, una tensión, todos esos electrones se van a desplazar en el mismo sentido, en la misma dirección. Eso es lo que se conoce como corriente eléctrica. Eso se puede explicar con un texto muy breve y muy sencillito como este de aquí. Y por último, pues yo añadiría que la definición de material conductor y material aislante, y con eso creo que está bastante ya resumidito. Vamos a pasar al siguiente punto del tema, circuito eléctrico y simbología.
An electrical circuit is a closed path where the electrical current can flow. We use that current to light a bulb, power an electric motor, and many other things. If the circuit is open, no electrical current can flow.
So, as long as there is a closed path, current will flow along the circuit and the light will be on, but if we click on the switch, circuit will be open and no current can flow at all. Be careful here because it's a common mistake to think that electrical current will flow to the point where the circuit is interrupted. This is not true. If the circuit is not completely closed, electrons won't even start moving.
Let's take a look at basic symbols. This is a power cell or battery. They transform chemical energy into electricity. It's a source of constant voltage that we use a lot to power electronic devices. This symbol represents a switch. It can be represented open or closed. This is what you use at home to turn lights on and off. This represents a light bulb. I'm sure you have used them a lot. Electrical motors are very common. They transform electrical energy into motion. Resistors can be represented by either of these symbols. Resistors resist to the electrical current through themselves, and they heat up as they do. That's why we use them in heaters or in toasters. They are also very common in electronics, where they are used to control the electric signals. Fuses are safety devices that we put in the path of electric current in order to protect other elements in the circuit. Fuses will melt if the current through them is too strong, opening the circuit and therefore stopping the electric flow from damaging other elements in the circuit. Push buttons are like switches, but they only close the circuit while they are being pushed. They are everywhere. This switch is a bit different. You have also used these ones at home, but you probably haven't noticed. They change the path of the electric current into a different circuit. They are very useful.
And there are so many other symbols, but for now, this is more than enough.
Let's learn the difference between series and parallel circuits. Components connected in series are connected along a single path, so the same current flows through all of the components. Components connected in parallel are connected along multiple paths so that the current will split up.
Okay, so I am using this software called Crocodile Clips for circuit simulation. It's a very old software, but it's very simple and it's perfect for you to start with this. And I'm going to try to build the circuit in series that we just saw. I'm taking a battery here, and now I am going to look for the light bulbs. Here is one. I'm going to put this here and another one here like that, and another one like this. I'm going to wire them. I only have to click from one point to the other. And as you see, when I finish connecting everything, the lights turn on. I am going to try another switch. I'm going to use the crocodile to cut this wire, and we have switches here. So I'm going to put this one here. I have to wire it. Okay, there you go. And now I can use it to turn it on and off. Okay, the next thing I'm going to do is to build this same circuit, but using the pictures. This software has pictures in it, so I can use the symbols or the pictures. I can change that here, pictures. So now I have here this battery. I'm going to change the zoom. All right. And I'm going to try and build the same circuit here, but with real elements. We have light bulbs here. I'm going to put one here, another one here, or here, and another one here. And I will wire them with care. This point here is the positive terminal, which is this point in the battery symbol. So careful when you wire. This goes here. This goes here. Next one. And I have to close the circuit to make it work. There you go. I can try and put a switch here. This one. Okay. And when I click here, they start just as they do here. Next thing I'm going to do is to build the parallel circuit. All right, now that I have both circuits, this is the series circuit, this is the parallel circuit. I want you to see two main differences that are between these two circuits. The first one is that if I turn both on, you will notice that these light bulbs are far more illuminated than these ones. And the battery is the same voltage, it's 9 volts. That's one thing. We will learn in the next lesson why this is happening. And also what I want you to understand is that in a circuit that is in series, if let's say this light bulb breaks and I have to replace it, obviously when the light bulb breaks, the circuit is open and the current will not flow. If I switch this on, the other light bulbs won't turn on. But in the parallel, if I have to change a bulb or this component breaks, when I turn this, the other two will still work because the current still has a path to come back and keep flowing through the circuit. Okay, now I want to show you these two circuits. This one has a push button that activates that motor here. And this one here is a battery with 3 light bulbs. And I would like you to try and draw them in your notebook using the symbols. It's very simple, but just be careful with the connections, ¿ok? Vale, pues ahora lo que os propongo es que, igual que en el vídeo anterior, hagáis un resumen de lo que habéis aprendido en esta sección. Os recuerdo, hemos visto la definición de circuito eléctrico, la simbología básica, la diferencia entre circuito serie y paralelo y, por último, tenéis una actividad propuesta que es dibujar con símbolos los dos circuitos que he montado al final con Crocodile. La idea es que después puedas estudiar de tus apuntes sin tener que volver a ver los vídeos enteros. Así que te recomiendo que hagas todos los dibujos que sean necesarios y apuntes las palabras en inglés que quieras recordar. Mucho ánimo.